All right, my friends, now we're going to jump into static routing. And you got a sneak peek of static routing, or add static routing, I should say, in the introduction to routing processes part of the course. But now we're going to start configuring it on live Cisco routers. I've got a config or two up on the board for you as well, but just about everything we do here is going to be on the live equipment. For that reason, you may want to jot this diagram out now, because while we're going to refer back to it once or twice, when we're on the live equipment, you won't be able to see the diagram. So if you want to draw this out, it is a good idea. Router 1 is going to be our hub router in our hub and spoke network. And the only interface that I have up and running on that one is the serial interface. And it's at 172.12.123.1. Router 2 and 3 are going to be our spoke routers. And you see the serial interfaces, the IP addresses that I've given them from the 172.12.123.0/24 network. And I've configured a loopback on 2 and 3, and that's going to give us a couple of extra networks to work with as we check out or do a lot of connectivity tests in this particular lab. Now again, we're dealing with a hub and spoke network here, and a very important concept to keep in mind. I'm going to repeat this until you get tired of hearing it. You're going to be throwing things at the screen. But you got to keep this in mind. It's really easy to overlook when you're looking at diagrams like this. Anytime a spoke sends traffic to another spoke, it's always going through the hub. And we do a lot of hub and spoke networks in this course, so it's something we've just got to keep in mind. Now, as far as the loopback goes, those are logical interfaces. They don't physically exist on the router. They're going to be up and up, so to speak, physically and logically fine as soon as you create them, because they don't really exist. Now, a question I'm always asked at this point, of course, well, why do we have these? And there are plenty of reasons. A few you're going to run into this course, and a few you're going to run into in other courses, because some of them do have to do with really advanced routing concepts, and we need to go over the fundamentals here first. That's what the CSEN's all about. One great use for loopbacks, though, in lab environments like the one we have here, is that we get to create as many networks as we want. So we're not limited to, okay, I got 4 interfaces on this router, therefore I can only use 4 networks. I can create as many as I want, and that's what we've done here as well. Another organizational tool I would really recommend to you, don't get too cute with your IP addresses when you start working with labs. What I always like to do is make the last octet of the IP address the router number. It's really great to look at .4 in a bigger lab and say, okay, I know that's router 4. If you start ending them in 111 or 112, it's like, okay, do I have that many routers? Hopefully not. It's just a good organizational habit to get into for your home lab studies. And what I like to do, especially when I'm going to have one loopback on an interface for a lab, is that I will just make each octet the router number 2222 and so forth. Just a couple of organizational tools there for you. Here on the board, you see the networks we're using in this section. And in a moment, we're going to use our first pings, because we are going to be sending pings everywhere during this lab and our OSPF labs, EIGRP labs, and some other ones we've got set up as well, because we always want to test our connectivity. And as we've discussed before, but now you'll see live, we're sending 5 ICMP echo packets to the IP address that we specify. If we get 5 echo replies in return, which is great, you're going to see 5 exclamation points, and that means you have connectivity to whatever destination you put in. So let's go ahead and test that ping first. The screen may come up, a little bit on the side. Let me move that. And we're going to go over to router 1. Do a ping 172.12.123.2, and then I'll do an up arrow and just back up over the 2 and type in 3. And that is what a successful ping looks like. There is an extended ping command that I'll show you in the CCNA course, and that gives you options as to how many packets you want to send out, how big you want the echo packets to be, all kinds of other options, more options than you're ever going to use in this life and maybe the next one. But there are some helpful options in there. But right now we're going to stick with the extended ping. We're sending 5 100-byte ICMP echoes out and hopefully getting 5 replies back. And there they are. So right now we've got connectivity in our network. Let's go back to the diagram for just a moment. Or 2. That's what we call a pregnant pause, where I say, what just happened here? So we've got routers 1, 2, and 3 here. We have no routing protocols. I haven't configured anything on here except the IP addresses. So how can router 1 ping router 2 and 3 right now as far as the serial interfaces go? We've seen the pings. Now let's take a look at our routing table. And you're going to see all those extra codes I mentioned a couple times. See, I told you that this area got a lot bigger as we went along. I think I was just showing you this earlier in the printouts, but these are all the route types that you're eventually going to know. And I don't even mean in this course. We're not going to go over all of them in this one, but don't let it intimidate you. We're going to learn one at a time, one code at a time, and it's all going to be good. Now, we don't have a gateway of last resort set. That's fine because that's not going to be set by default. And right now we have exactly one connected route, but it's enough because the two destinations we pinged were on the 172.12.123.0 network. They were .2 and .3. So it's directly connected serial 0. It's the one route that we have in router 1's routing table, but that is perfectly fine. That's all we needed to send those pings, and that's why we were able to ping them. And here's exactly what happened when we sent that ping and then the ping reply. Because remember, R3's got to answer R2's ping. And when that happened, anytime we send pings from one spoke to another, it's always going to go through the hub. And let's go ahead and send those pings too. Actually, I meant to do this here. I stepped out of order. Sorry about that. Here's the ping we're going to send now. And we're going to send that from 172.12.123.3. Let's go over to router 2. Can ping the hub router with no problem, but can it ping the other spoke? And it can. So no problem there. 2 can ping 3. And this is exactly what just happened. The ping went up to router 1, which is our hub, came right back out router 1 down to 3, and the ping was successful. Sorry, I got my screen a little out of order there. And there's the ping reply that we saw come right back, and that's why we got our 5 exclamation points. Now, I know that you may look at the question, can R3 ping .1 and .2 and just say, well, of course they can. We already sent those pings out. But always send your pings around at the beginning of a lab. It's just a really good idea, even if you know they should go through, because what will happen if they don't go through and you don't test them is that you configure something and then you think, when it doesn't work, you think, hey, my configuration is wrong. Or what I just put on here, say OSPF was wrong. Well, that wasn't what was wrong. Something else fundamental was wrong. So always check your labs out for basic connectivity before you start a lot of configuring. So right now, no problem at all. All 3 devices, all 3 routers can ping their 2 compatriots. And let's go down here. No problem at all. The ping goes through. Every router has an entry for 172.12.123.0/24, so there's no problem. So let's see now if router 3 can ping router 2's loopback, and if not, why? Because I did say on the screen there that it wasn't going to go through. And you can occasionally lose one ping packet when you're pinging a destination for the first time, and then you get 4 exclamation points, and you'd see a success rate of 80%. That's actually okay. Just send it again immediately, and you should see 100%. Here, however, we're seeing 0%. We sent 5 ICMP echoes, and everything else is the same, and here's our address, and they couldn't get there. So why not? Well, you probably already know why. But as your network grows, it's not always going to be easy to diagnose this particular kind of problem. And that's why I want to introduce you to a new friend of ours, Debug IP Packet. Because ping is just about always going to be the first connectivity test that you run. But it's a very fundamental test. It's really not giving you a lot of information. It's almost, does this exist? Does this connectivity exist, or does it not? And when the answer is it doesn't, as in this particular case, this really isn't telling us anything right here. It's just saying, hey, we can't connect with 2222. We don't have any connectivity. There's no real hint as to why. So at the beginning of the very next video, we're going to dive into Debug IP Packet. But I do want to give you a bit of a warning here and a study tip. because this is one thing I really wish someone had told me when I was studying for the initial Cisco exams. The CCENT did not exist. The CCNA was the first one you could get. And I really wish someone had told me this, and I've always liked to teach like this, like, hey, do this. Debugs. Debugs are an outstanding learning tool. And if you have access to a home lab, if I don't know if the simulators like GNS3 really run debugs well. I think they do for routers. Of course, GNS3 you can't run switches. But anytime you can use debugs in a non-production environment, I urge you to do so, because it allows you to see what I call what goes on behind the command. You know, knowing the command is one thing, but knowing what's going on because of that command is another. And it really helps drive home the learning process. It really does. And it's one thing, again, I really wish I'd known about when I was going after my first Cisco certification. Now, do not practice debugs on a production network. I cannot stress this enough. Some debugs, especially debug IP packet, it can actually overwhelm a router or a switch CPU and render the device unable to function. I've actually had that in a lab environment. I ran debug IP packet on a very busy router in the middle of a lab, and it got so busy showing me all the output that I literally could not interrupt it. I had to reboot it. So again, you never ever want to practice debugs at work anyway. You never want to do that. Now, another reason that I really want you to run debugs is that you need to run them when things are working correctly, so you know what you're trying to get to when they're not working correctly. You don't want to just run debugs when something goes wrong, because sometimes the debug is going to be obvious. It's going to say, hey, you know, here's your problem. We're going to see a couple of those in this course. But a lot of times it just says, well, here's the information you wanted. It's not saying, hey, Chris, here is the problem that you are having right now. It's just going to give me screens and screens of information. I'm the one that has to interpret it. You and I, that is, as network admins. And the only way to really know or spot a problem is to know what the debug output looks like when things are working well. That's really, I think, the number one error I see when people practice their Cisco skills is they only run debugs when something isn't working. Run them when they are working too, and just have a look, see what's going on, and then you can turn the debug off and move on through a lab. Okay, so that's the importance of debugs, where to run them and where not to run them. When we come back for the next video, we're going to run that debug on router 3 and then send some pings around, because we know we can ping router 2 from router 3 as far as the 172.12.123 network goes. We know we can do that. So what we'll do is run a debug when we can do it, see what that looks like, and then we'll run a debug on something we can't ping, and we'll compare the two. So we'll do that on the very next video. See you there.